The universe is vast, mysterious, and full of secrets. For centuries, humanity has gazed at the stars, attempting to understand what lies beyond our world. But as powerful as our telescopes have become, and as deep as our scientific understanding has grown, we've discovered something extraordinary. Most of the universe is made of something we cannot see, cannot touch, and cannot fully explain. This invisible ingredient is what scientists call dark matter. But what exactly is it, and why is it so important? The story of dark matter begins nearly a century ago. In the 1930s, Swiss astronomer Fritz Zwicky studied the Coma galaxy cluster and noticed something unusual. The galaxies inside the cluster were moving far too quickly to be held together by the gravity of visible matter alone. By all logic, the cluster should have torn itself apart, but it didn't. Zwicky proposed that there must be some hidden mass, an invisible form of matter that was exerting gravitational pull. He called it dunkle materia, or dark matter. At the time, his idea was radical. Many dismissed it, but over the decades, more evidence piled up. Fast forward to the 1970s. Astronomer Vera Rubin made a groundbreaking observation. When she measured the rotation speeds of stars and galaxies, she expected to see stars at the edges moving slower, much like planets in our solar system. But instead, she found the stars on the outskirts were moving just as fast as those near the center. This was impossible if only visible matter existed. Something invisible had to be adding extra mass, keeping galaxies from flying apart. Once again, dark matter was the answer. Rubin's work cemented the idea that dark matter wasn't just theoretical, it was real, and it dominated galaxies. Here's where things get even stranger. Dark matter doesn't emit light, doesn't absorb it, and doesn't interact with electromagnetic forces at all. In other words, it's completely invisible. Scientists only know it exists because of its gravitational effects. But what could it be? Some theories suggest dark matter is made of exotic particles called WIMPs, weakly interacting massive particles. Others propose axions, incredibly light particles that fill the cosmos. More radical ideas suggest that maybe we don't need dark matter at all. Maybe our understanding of gravity itself needs to change. Yet, so far, dark matter remains the leading explanation. Without dark matter, the universe as we know it would not exist. It makes up about 27% of the cosmos, compared to just 5% for ordinary matter, the stuff that makes up stars, planets, and people. Dark matter acts like a cosmic glue, holding galaxies together, shaping their structures, and influencing the formation of the large-scale web of the universe. In fact, without it, galaxies would never have formed in the first place. Dark matter is the invisible scaffolding that allowed stars and galaxies to take shape after the Big Bang. Scientists around the world are trying to detect dark matter directly. Deep underground labs house detectors shielded from cosmic rays, waiting for a rare interaction with dark matter particles. Massive experiments like the Large Hadron Collider search for hints of new physics that could reveal dark matter's identity. So far, the results remain elusive, but every year we get closer. It's important to note that dark matter is not the same as dark energy. While dark matter pulls galaxies together with gravity, dark energy does the opposite. It pushes the universe apart, driving its accelerated expansion. Together, they form the mysterious dark universe, which makes up a staggering 95% of all that exists. Humanity only understands the remaining 5%. So, what is dark matter really? The truth is, we don't know yet. It could be particles we haven't discovered, or perhaps an entirely new force of nature. What we do know is that dark matter is crucial. It shapes the universe, defines its structure, and holds the key to mysteries we've only just begun to uncover. Perhaps one day a breakthrough will reveal its true nature. Until then, dark matter remains one of the greatest enigmas in science, a reminder that the universe still hides secrets waiting to be discovered.